Good morning, it's Coach Jackson. Today we're going to talk about combinations of functions. And when you hear the word combinations, that should ring a bell to you as you are adding, subtracting, multiplying, dividing, or in some cases, plugging one function into another. So the first thing we're going to take a look at are the rules of combining functions. We've got addition, subtraction, multiplication, and division. We'll look at examples of those. So we have f of x is x squared plus 2x. And we have a different function, g of x is 2x plus 1. And we want to take each one of those operations that we saw on the first page of notes and combine these functions in some way. First thing we want to do is add them. Well, remember, you can only add terms that are alike. So if we take our x squared plus 2x and we add it to the 2x plus 1, the only like terms we have are the two x's, and they combine to give us a 4x. So the answer for this one is x squared plus 4x plus 1. If we take those same two functions and we subtract them, don't forget when you're subtracting, you have to distribute this negative. So it would be x squared 2x minus 2x minus 1. In this case, two x's would cancel each other out. They're like terms. We can combine them. They combine to 0. We get a final answer of x squared minus 1. Multiplying. We're multiplying a binomial times a binomial, so you can either use distributive property, FOIL method, box method, whichever one's comfortable for you. So if I multiply these, x squared times 2x is 2x cubed. X squared times 1 is x squared. 2x times 2x is 4x squared. And 2x times 1 is 2x. Now I can combine any like terms, but it just so happens there are not any. But I do want to write my answer, my final answer, in standard form. Take that back. We got some like terms right here. Combine those and we get 5x squared. So 2x cubed plus 5x squared plus 2x. Again, if I'm going too fast on the video, please pause it at any time. Division. Lots of times division, there's not a lot of work you can do with it unless you can factor it and cancel some things out. So if I take my f divided by my g, x squared plus 2x divided by 2x plus 1, I want to look at factoring and canceling. Well, I can factor the top. I can pull out an x. It doesn't really get me anywhere. Nothing cancels out. I want to write the domain. Remember the domain for a fraction, take the denominator, make it not equal to 0. So if I take 2x plus 1 not equal to 0 and I solve, not equal to 0, excuse me there, divide by 2, my domain cannot include negative 1/2. So to write that in set notation theory, it's negative infinity to negative 1/2 in parentheses, union negative 1/2 to infinity in parentheses. So that's an example of adding, subtracting, multiplying, and dividing functions. Now, once you've done those operations, they may want you to evaluate your function at a specific x value. So if I take f times g and I evaluate it at 2, meaning I plug in 2, you can plug in the 2 before or after you do the multiplication. It doesn't matter. So here we plugged it in before, and it worked out to give me 40. So x squared plus 2 times x, I plugged in the 2. 2x plus 1, I plugged in x is 2. Here we want to use the f minus the g and plug in 2t squared wherever I see an x. So if I plug in 2t squared wherever I see an x, x squared plus 2x, this used to be an x, that used to be an x, that used to be an x. I plugged in 2t squared, and I do the math. 2t squared all squared is 4t to the fourth, and so on down the line. Here I got 4t squared plus 1, and I combine any like terms. 4t squareds cancel each other out, and I get 4t to the fourth minus 1. All right, moving on. Here we want to find f times g of x and f divided by g of x. My functions are x plus 6 and g of x is square root of 2 minus x. So if I do f times g, that's multiplication. Okay? Multiplication. We'll be multiplying them. There's not much we can do here. We can do the x times the square root of 2 minus x and the 6 times square root of 2 minus x. Okay. So that's a distributive property. If I do the division, I got x plus 6 over square root of 2 minus x. But remember in math, you cannot leave a radical in the denominator of your answer. So I need to multiply this by the conjugate. So I want to multiply the numerator and denominator by square root of 2 minus x. So I've got top times top, bottom times bottom. Okay, we've got x plus 6 times square root of 2 minus x. And when I multiply the 2 here, square root of 2 minus x times square root of 2 minus x, I get just 2 minus x. What's my domain? Well, if I take 2 minus x and I set it not equal to 0, and I solve, x cannot equal 2, right? What's wrong with my answer? I've also got a radical in my answer. So I have to allow for that also. It's got to be greater than or equal to 0. So when I do this math, and I get here, well, this says I cannot equal to, and this says I can. Well, here's how you fix that. Take that little equal to off, and you get an answer for your domain of x less than 2. X has to be less than 2. So that's negative infinity to 2 in parentheses. So we had two issues with domain that we had to combine down into one here. Can equal 2, so you got to take that equal sign off. Now we're getting into where we plug one function into another. And that's what this open circle right here means. Plug one into the other. It's not a multiplication. Multiplication, it would be a closed circle, a dot. Okay? Whichever one is listed second, you plug into the first. So this reads f of g of x. G is listed second. I'm going to take whatever function g is and plug it into f. So here's another way to write it. So wherever I see an x in the f function, I'm going to plug 2x plus 1. So I'm going to take 2x plus 1, and we'll plug it here, and I'm going to plug it here. That's f of g of x. So I take 2x plus 1, plug it in for this x, it's squared. 2x plus 1, plug it for this x, 2 times that x. And I do the math. I got to square this one and multiply that one by 2. So this one's going to be 4x squared plus 4x plus 1. This one's going to be 4x plus 2. And I'm going to combine any like terms. The 4x's are alike, and the 1's and the 2's are constants, so they're alike. So my final answer should be 4x squared plus 8x plus 3. All right, moving on. We want to find g of f of x. So I'm going to take f of x and I'm going to plug it into g. Okay, let's go back up to the top here. So now I'm going the other way. I want to take this one and plug it wherever I see an x in g. Okay, that's what I'm doing on this one. So I'm going to take that x squared plus 2x and I'm going to plug it in for x. Okay, this used to just be an x right here. All right, I'm going to do the math. I'm going to distribute the 2 and add the 1. And I get 2x squared plus 4x plus 1. And the reason we're doing this is you're going to need it for the next section when we talk about inverses of functions. Now, sometimes you got to look at graphs and be able to find the composition of the function. So here in number 1, this is the graph of f of x. This is the graph of g of x. I need to find f of g of 1. Well, you know that 1 is the x. So in g, I want to find out what's the answer when x is 1. So over here in g, when x is 1, my graph is over here at 2 on the g of x, right? This is x, this is g of x. Okay. So that becomes 2. Then I want to find f of 2. So I go here to the x on the f of x graph at 2, and I'm at 5. F of 2 is 5. So that would be my final answer. F of g of 1 equals 5. We'll do another one. All right, the next one is g of f of 4. So we look at f first at 4. And I'm sitting here at 3. F of 4 is going to be 3. Then I'll go over to my G graph and look at 3. 1, 2, 3. I'm up here at 1, 2, 3, 4, 5, 6. Should be my answer for that one. Okay, 6 is the answer for that one. So take whichever one's inside first, find that answer, and then work your way to the outside. All right. Next time we'll talk about inverses. Have a good day.